Hello students, today we will do an experiment to turn on three LEDs which are connected in series. The components required to do this experiment are a battery and a battery cap and three LEDs 1, 2, 3 and 100 ohm resistor and one connecting wire and a breadboard. Let us do a connection. First we will connect the battery cap to the battery. Connect the positive terminal of the battery to the power rail of breadboard, one of the point to the breadboard, and the negative terminal of the battery to the other line, other vertical line. So the first point is positive supply and the second point is negative supply. Now take 100 ohm resistor. Connect one end of resistor to positive supply, that positive terminal of the battery, and other end to anywhere on the breadboard. Now take a white LED. It has got two terminals. The long lead indicates anode and a short lead indicates cathode. Connect anode to the one end of resistor and other end to another point on the breadboard. Now we will connect red LED in series with the first white LED. Red LED has got two terminals. Long lead is anode, short lead is cathode. Connect anode to the cathode of the first LED and cathode to anywhere on the breadboard. Now we will take another LED, white LED. So the long lead connect it to the cathode of the red LED and cathode to anywhere on the breadboard. Now we will complete the circuit by connecting a wire. Connect one end of the wire to the cathode of the third LED and other end of the wire to ground. Ground is the second line. Now the LED, all the three LEDs are turned on. In this experiment we have used 9 volts battery. So the forward voltage drop for white LED is between 3.0 to 3.6 volts, and for red LED it is 1.8 volts to 2.2 volts, and for green LED it is 2.0 to 3.0. So since these three LEDs are connected in series, all the forward voltage drop we must add. So after adding all three voltages, it should be less than or equal to 9 volts. If it exceeds more than 9 volts, so the LED will not glow. Let us connect the same two green LEDs in series. Now we will remove red LED and I'll connect, in place of red LED, I'll connect green LED. So I am connecting green LED in series with the another green LED. See, now the LEDs are not giving the light. They are not turned on. Now let us check with white LED. Again, the LEDs are not turned on. Now we will remove white LED. We will connect back red LED. Now I connected back red LED. So all are turned on. So the first LED is white, the second LED is red, and the third LED is green. So why when I connected red, white and green LED with 100 ohm resistor, they all turned on. When I connect two green LEDs and one red LED, or one red LED, or two red LED and one green LED, or two white LED and one red LED, they are not turning on. Why this happens? Let us assume the forward voltage drop for a red LED is around 2 volts, and for green LED is 2.2 volts, and for white LED is 3.2 volts. So since they are connected in series, and let us assume the current in each LED is 20 milliamps, that is 0.02 amps. In series circuit, the total forward voltage across the LED will be the sum of forward voltage, because since they are connected in series, the total voltage drop is sum of forward voltage drop across each LED. For red LED, I assumed 2 volts, 2 volts plus. For green LED, it is between 2 to 3. So I am taking it as 2.2 volts. And for white LED, 3.2 volts. And total voltage drop is 7.4 volts. To find out the voltage drop across each resistor, so we have to subtract this voltage from the total battery voltage. The total battery voltage is 9 volts and we got the summation 7.4 volts. So I got the difference, that is voltage drop across each resistor is 1.6 volts. To calculate the resistor value, let us apply Ohm's law, that is R is equal to V by I. R is equal to 1.6 volts, just now we got, divided by 20 milliamps is nothing but 0.02 amps. I will get 80 ohms. Therefore, you need a resistor value of approximately 80 ohms to connect red, green and white LEDs in series with 9 volts battery with a desired current of 20 milliamps flowing through each LED. Please note that the resistor value calculated here assumes the ideal voltage drop for LED. It may not match the exact characteristics of your specified LEDs. It's good practice to consult the data sheet or a specification of your LEDs for accurate voltage drops and to choose the nearest standard resistor value that is available. So since I got 80 ohms, so I don't get a 80 ohm standard value. So because of this, I am connecting 100 ohm resistor in series with all three LEDs. So this is my 100 ohm resistor. If I use two white LEDs and one green LED, what happens? So the white LED, I have considered the forward voltage drop as 3.2 volts. So 3.2 volts, another 3.2 volts, it becomes 6.4 volts. And if I use one green LED, 6.4 plus 2.2, 8.4. So it is almost reaching 9 volts. Just now we saw when I connect two white LEDs and one green LED, the LEDs will not LEDs they did not give the light, they did not turn on. So to overcome this problem, what I have used, one red LED and one green LED and one white LED I have used. So the total voltage drop now I am getting 7.4 volts. So which is very much less than 9 volts. So all LEDs are turned on. So I have used here 100 ohm resistor. So you may ask, if we don't connect resistor also, is that okay? If all LEDs will turn on, if you have this question, so definitely no. So why it is no? Because it is not recommended to connect LEDs directly in series without resistor, especially when using 9 volts battery. Since LEDs are current driven devices, and their forward voltage drop varies depends on the color. Without resistor in series, the current flowing through the LEDs would be uncontrolled. So potentially they exceeding their maximum ratings and causing damage. And if they are connected in series without current limiting resistor, LED with lowest forward voltage drop. For example, lowest forward voltage drop is for red LED 1.8 to 2.2 volts. So it will draw most of the current and resulting in uneven brightness and potentially damaging the LED with lowest forward voltage drop. To ensure proper operation and protection of LEDs, it is strongly recommended to include a current limiting resistor in series with LED or use a dedicated LED driver circuit. In this way, you can connect 3 LEDs in series with 9 volts battery, and remember, we should connect a current limiting resistor to protect our LEDs. Thank you for watching the video.